Hello everyone, welcome back to Geeks for Geeks. I'm Kunal and today we'll be solving the problem named meeting rooms. In the problem statement, we have given an array ARR such that array of I of 0 is the starting time of ith meeting and array of I of 1 is the ending time of ith meeting. So we have given a 2D array which contains of different arrays of size 2 in which our first element represents start time of some meeting and our second element represents ending time of that meeting. The task is to check if it is possible for a person to attend all the meetings such that he can attend only one meeting at a particular time. So we have given timings of some different meetings and we have to check whether it is possible for a person to attend all the meetings if he can attend only one meeting at a particular time. So we have to check whether any of the meeting has some overlapping time or not. If the timing is overlapping, then it won't be possible for that person to attend all the meetings. A person can attend a meeting if its starting time is greater than or equal to the previous meeting's ending time, right? If other meeting is starting after the ending of previous meeting, then only our person will be able to attend that meeting. Otherwise, it won't be able to attend that meeting. Let's understand this question with the help of an example. Here we have an example. We have timing of three meetings. First meeting is starting at 4, ending starting at 1, ending at 4, and second meeting is starting at 10, ending at 15, and this meeting is starting at 7 and ending at 10. Right? So we have to check whether our person will be able to attend all the meetings or not. Here we have a number line which represents the timing of all the meetings. First meeting is starting at 1 and ending at 4. This will be the timing for our first meeting, and this meeting is starting at 10 and ending at some 15. So this will be our this meeting, and our this meeting is starting at 7 and ending at 10. So this will be our third meeting. If the person attends all the meetings, will there be any overlapping? We can see that there's 10 common in both. Like one meeting is from 10 to 15 and other is from 7 to 10. But it will be possible for the user to attend these meetings as one meeting is ending at 10 and other is starting from 10, right? As it is written in the note, a person can attend a meeting if its starting time is greater than or equal to the previous meeting's ending time, right? So its starting time is equal to the previous meeting's ending time. So it will be feasible for the person to attend this meeting. The output for this problem will be true, right? For this test case, the output will be true. Now let's see one more test case. So here we have another test case. We have 2, 4, 9, 12 and 6, 10. So how will the meeting goes? First meeting goes from 2 to 4. Second meeting goes from 9 to 12. And this third meeting goes from 6 to 10. As you can see in this time span of 9 to 10 is being occupied by our two meetings, 6 to 10 and 9 to 12. Our person will not be able to attend all the meetings as there is overlapping of 1 hour in these both meetings. So output for this will be false. So we can see that for a meeting to be overlapping, its starting time is greater than the starting time of other meeting. In this 9 to 12, the starting time of this meeting is greater than this 6, and also the starting time of this meeting is smaller than its ending time. So it will surely lie somewhere between this meeting, right? As it is starting after this, but it is also starting before its end, right? It is starting when one meeting is still going on. So we can say that they will surely overlap. We can use this. So as for our brute force approach, what we will be doing, we will be running two for loops for I, we can say from 0 to n, and other will be from I plus 1 to n. And in that for loop, we will be having two conditions. We will be checking if the starting time of one meeting is greater than other, and if starting time of that meeting is greater, whether it is also smaller than the ending time of that meeting. If it is, then we will return false. And similarly, we will also have one other condition. If starting time of a meeting is smaller than the starting time of other meeting, but the ending time of that meeting is greater than the starting time of other meeting, then we will also return false. We can implement these if conditions. There will be two if conditions, or we can use a or operator in a single if conditions. And each of our if condition will be having two conditions separated by an and operator. If like array of I of 0, array of I of 0 is lesser than array of j of 1, array of j of 1, and array of j of 1, sorry, array of j of 0 here, and array of j of 0, the starting time of other meeting is also lesser than ending time of our first meeting. And we will be having a similar condition but in reverse, right, in other if condition. And if this is happening, then we will be returning false. What will be the time complexity of the solution? The time complexity of the solution will be of n square, as we will be using two nested loops, each running up to n. So the time complexity for the solution will be O of n square. So we will try to optimize this. So how can we optimize this? Let's see the optimization. We will use sorting to optimize this. By sorting, we will have all the meetings in a sorted manner. We will be having all the meetings, like we will be having our first meeting, then second meeting, then third meeting. All the meetings will be arranged according to their time, right? Which meeting will be occurring after another. So like here in this, we have this array. It contains of three meetings, and it has 2, 4, 9, 12, and 6, 10. And after sorting, it will become 2, 4, 6, 10 goes here, as 6 is smaller than 9, and our 9, 12 remains same. If we know only this meeting will be starting after this meeting, like our I plus 1 will be starting after I. So we just need to check whether the starting time of this meeting is greater than the ending time of this meeting. So we just need to check whether the starting time of this meeting is greater than the ending time of this meeting or not. If starting time of this meeting is greater than the ending time of this meeting, then what we will do, then we will be moving ahead. But if somewhere the starting time of next meeting is smaller than the ending time of our current meeting, right? The starting time of I plus 1, like we say starting time of I plus 1, and ending time of our current meeting, I of 0, let's say ARR. If starting time of next meeting is smaller than ending time of our current meeting, then what we will do, we will return false, because in that case we can't attend that meeting because it is starting before the ending of our current meeting, so it is not possible, right? So let's see how we will code this. Here's the code for our optimized approach. What we have done, we have simply created a n which is equals to size of variable, and now we have sorted our array. By sorting, our all the meetings are now arranged in a timely format, and we are running a loop from 0 to n minus 1. We have called it up to n minus 1 because we will be accessing I plus 1. If we have called it up to less than n, we won't be able to access this I plus 1. Now we will be comparing our ending time of our current meeting, end time of current, and start time of next, right? We will be comparing both of them. If end time of current meeting, if it is greater than start time of next meeting, then we, our user won't be able to attend this next meeting. Then what we will do, we will be returning false. If somewhere in the meeting this condition satisfies, our false will be returned. If nowhere in our array this condition is satisfying, then we will be returning true. This was our today's problem of the day. I hope you all understood it. Thank you for watching.